All right, section 9-5, congruence transformations. All right, look at the congruent triangle. So draw line segments that match corresponding sides. So in this figure here, AB is going to correspond to DE, BC is going to correspond to EF, and AC corresponds to DF. All right, angle A corresponds to angle D, angle B corresponds to angle E, and angle C corresponds to angle F. So two figures are congruent if and only if there is a sequence of rigid motions that maps one figure onto the other. So if a triangle is transformed by the composition of a reflection and a translation, the image is congruent to the given triangle. So circle the transformations that make up a glide reflection. That would be a translation and a reflection. When a figure is transformed by an isometry, what is true about the corresponding angles and corresponding sides of the image and pre-image? The corresponding angles and sides are congruent. Okay. So the compositions, we do a reflection and a translation of this triangle. List all equal angle pairs and all equal side lengths. So angle A is going to be congruent to angle X. Angle B is congruent to is equal to angle Y, and C is equal to Z. All right, AB will be corresponding to XY, BC will be corresponding to YZ, and AC will be corresponding to XC. So two figures are congruent if and only if there's a sequence of one or more rigid motions that maps one figure onto the other. So which pairs of figures in the grid are congruent for each pair, which is a sequence of rigid motions that map the other to the other? So to map triangle ABCD onto parallelogram HIJK, we're going to translate ABCD 6 units to the right and 5 units down. To map triangle UVW onto triangle QNW, we're going to reflect it across the line y equals 0, and then translate this triangle 6 units left. Because T of 6, negative 5, the parallelograms are congruent. Because T of negative 6, 0, and the rotation of y equals 0, these two triangles are congruent. All right. So what is the congruence transformation that maps triangle NAV to triangle BCY? All right. Well, what do we need to know? We know the pre-image and the image. So N is at 1, 5. A is at 4, 3. V is at 0, 1. B is at negative 4, negative 5. C is at negative 1, negative 3. And Y is at negative 5, negative 1. I need to determine the rigid motion or sequence of rigid motions that maps triangle NAV onto triangle BCY. So my plan, my vertex N corresponds to vertex B, A corresponds to C, and V corresponds to Y. It appears NAV has been reflected across the x-axis or the y-axis and then been translated 5 units to the left and 0 units down. All right, so let's try this. So verify the vertex N corresponds to vertex B. All right, so 1, negative 5 becomes negative 4, negative 5, and that is vertex B. All right, let's make sure it's C. So into the x-axis of A would be 4, negative 3. All right, and then negative 5, 0 becomes negative 1, negative 3, which is vertex C. All right, x-axis of V becomes 0, negative 1, and then negative 5, 0 becomes negative 5, negative 1, which is vertex Y. So the congruence statement would be the following. All right, verify the SAS postulate. So first verify the SSS postulate. So if I'm given 3 sides are congruent, prove these triangles are congruent. All right, so first we're going to rotate triangle SNE about the point S so that NE is parallel to DT. Then translate triangle SNE so that points S and Y coincide. All right, there is a congruent transformation that maps this triangle onto that triangle. So triangle YDT is congruent to triangle SNE. This verifies the SSS postulate. So is a composition of a rotation followed by glide reflection a congruent transformation? So list the 4 isometries in the line below. So the 4 isometries are transformation or translation, reflection, rotation, and glide reflection. The composition of 2 or more isometries is an isometry. So a rotation and a glide reflection are isometries. So the composition of a rotation and a glide reflection is an isometry. And that's the end of this section.